You know that this complicated polynomial on the left, that I'm not going to read because it's complicated, factors as x to the 6 minus 2x cubed plus 4, all times another polynomial p of x. What is the sum of the coefficients of p of x? And as a reminder, the coefficients of a polynomial are the numbers in front of the variable. As an example, consider this. There's a hidden 1, and the coefficients are 1, 2, and 4. So in this case, the sum of the coefficients would be 1 plus 2 plus 4, and that is equal to 7. If you want to give the problem a try, you can pause here. Technically, there are two ways to solve this problem, and one of them's really boring and really brute force. We'll start with the boring one, and that is long division. So if you did try this method and you managed to plunge through a bunch of algebra, this expression divided by x to the 6 minus 2x cubed plus 4, this ends up equaling x to the 12 plus 3x cubed plus 6. And then you can add together the coefficients. That will give you 1 plus 3 plus 6 equals 10. But this is really boring. By the way, in case you were wondering, I actually didn't calculate that using long division. I basically plugged it into Wolfram Alpha and let them do the work. I have better things to do than to plunge through long division every day. Anyway, now let's go to the smarter solution. The key to realize in the smart solution is that we're not required to figure out what p of x is. We just need to know the sum of the coefficients. So is there a way to figure out the sum without actually computing p of x? And to do that, let's first start with an example. Let's consider a of x equals 3x squared plus 4x minus 10. And let's think about what happens at a1. So a evaluated at 1. Substituting in 1 into our equation, we get this. Which, since 1 squared doesn't do anything, but this here is the sum of the coefficients. If you're not convinced that this works every time, let's just try a different example. Squared equals 5x to the 10 minus 8x to the 4 minus 7x. And b evaluated 1 equals 5, 1 to the 10 minus 8, 1 to the 4 minus 7, and 1. And this is exactly the same as the sum of the coefficients. The reason this works is that plugging 1 in basically gets rid of the variable, and all we're left with is the coefficient. And this is true for any polynomial. Using our result from before, we know that in order to calculate the sum of the coefficients of p of x, we just need to know what p of 1 is. We can realize that this left-hand side must always equal this right-hand side, regardless of what x is. So if it's true in general, it has to be true when x is equal to 1. We can substitute 1 into both sides of the equation, and this gives us 1 minus 2 plus 4 plus 3 plus 24. I'm not writing the 1 to the 18 and the 1 to the 15 just because it doesn't make a difference. And now we have 1 minus 2 plus 4 times p of 1. This left-hand side, when you add it, gives you 30. This here sums to 3 times p of 1. And we know that p of 1 is equal to 10. Notice that this is the exact same result we got when we did the brute force method. And this is a much nicer solution.